Hey guys, welcome to Nerd Central. Today, I'm going to be teaching you what a geometric sequence is. Hope you enjoy. Now let's get into the video. So as you can see, there's a formula that tells you any term of a geometric sequence if you know some things about it. So this formula essentially tells you what number term you want to find out. So that's what n stands for. As you can see, we have an example geometric sequence here too. In any geometric sequence, you multiply the next number by a certain amount. So as you can see in this geometric sequence, we're multiplying each number by 3. So this formula tells you any term in a geometric sequence. N is what number term it is. So this is term number 1, this is term number 2, this is term number 3, this is term number 4. And so we can represent those terms by writing a subset that number. So a subset 4 equals 27. So let's try to figure out the fifth term in the sequence. So we know that a subset 5 is equal to a subset 1. That's always the first term. So that's 1 times. So r is the number you multiply by. In this case, r is 3. 3 to the power of, so n, we want to figure out the fifth term, n minus 1, so 5 minus 1 is 4, 4. So we end up with 3 to the power of 4 times 1. So 3 to the power of 4 is 81. If you don't know what 3 to the power of 4 means, then we do have a video on exponents, and I will link that in the description. So that means A5 is equal to 81. And note, we can still easily check this too. If you think about it, we have 27, and we multiply by 3 each time. So the next term will be the fifth term. And 27 times 3, 81. So that's how to find any term of a geometric sequence. But there's another formula you can use with a certain type of geometric sequence. So we're going to talk about that next. So there are two types of geometric sequences. A finite geometric sequence, like this one, 1, 3, and 9, where there's only 3 terms. There's only a certain number of terms. It doesn't continue past, there's only a few terms. There can be a lot, but still not infinite. Then there's an infinite geometric sequence, where there are infinite terms, like 1, 3, 9, 27, 81, this one, where it keeps going and keeps going until it basically reaches infinity. So it's impossible to find the sum of a sequence that has infinite terms, but you can find the sum of a sequence that's shorter and doesn't have infinite terms. So we're going to try to find the sum of this simple sequence here, 1, 3, and 9. And it may seem like, oh, this is so easy, I can just do this by myself, in my head. But there might be bigger sequences. What if it was 1, 3, 9, 27, 81, 243? You don't want to find the sum of all those numbers. It would take way too long. And sequences can get even bigger than that. So that's why it's useful to know a formula. So we have S subset n is equivalent to A subset 1 times 1 minus r to the power of n over 1 minus r. So S subset n is equivalent to the number of terms in the sequence, which in this case is 1, 2, 3. So we have S subset 3 is equivalent to A subset 1 is the first term in the sequence, which here is 1 times 1 minus r to the power of n. So r is the amount you multiply by. In this case, r is 3. So 3 to the power of, and there are 3 terms, so 3 to the power of 3 divided by 1 minus r. So here's 1 minus 3. And so we compute this, we get, so it's equivalent to 1 minus 27, so negative 26, divided by negative 2, which is equivalent to 13. So now, since this is really simple, we can check this. 1 plus 3 plus 9 is 4 plus 9, 13. So that's how you find the sum of any finite geometric sequence. There is also a way to find the sum of some infinite geometric sequences, but they have to follow specific rules, and we're going to get into that next. So the type of infinite geometric sequence that can be summed up is a type where you multiply it, or like r is equivalent to a number less than 1, where it essentially gets smaller. Well, a number less than 1 or greater than -1, because if it's a negative number, so essentially between 1 and -1. As you can see, we have 2, 1, 1/2, and it gets smaller and closer to 0. And we have a formula for summing up all the terms in that sequence, and you get a number that isn't infinity. Notice how the s has no subscript, because there's an infinite number of terms. So you can't put a subscript down there, like n. So we have s is equivalent to a subset 1, which is the first term of the sequence, so this is 2, divided by 1 minus, so r. See if you can figure out what r is. If not, I'll just continue and tell you. So r is 1/2. Since basically you're multiplying the number by 1/2, you're dividing it by 2. And when you divide a number by 2, you're multiplying it by 1/2. If you can't figure out the logistics of that, just think about it a bit. I'm sure you'll understand. So 1 minus 1/2 is equivalent to 1/2. So we get 2 divided by 1/2. So when you divide a number by a fraction, you flip it around. So 2 is equivalent to 2 over 1. And when you divide it by 1/2, which is 1 over 2, you just multiply it by the flip side. So 1 over 2 flipped is another 2 over 1. So you end up with 4 over 1, which is equivalent to 4. So the sum of all the terms in this geometric sequence is 4. Now, there's no way for you to calculate this, but we can think about it logically and see that it does make sense that the sum of all the terms in this sequence are 4. So, as we can see, 2 plus 1 is 3. And then as you add 1/2, it gets closer to 4. As you add 1/4, it's 1/4 away from 4. When you add 1/8, it's 1/8 away from 4. And it gets closer and closer to 4. And so as you get an infinite number of terms, it gets infinitely closer to 4. So it'll eventually reach, so it'll never really reach 4, but since it's infinite, it does. It's a confusing concept, but it's something pretty useful in math. So that was the video on geometric sequences. Hope you enjoyed. Like and subscribe if you did, and I'll see you in the next one.